Greetings. I'm totally absent today, so I'm going to make this video for you guys to show you how to do this. It's going to be Tuesday, September 24th. And we're going to do how to make formulas for ionic compounds. Okay, so last time what we did is we learned how and why ions form. So it looked like this. This was actually a while ago, but we continued it yesterday with this right here. So we looked at these neutral atoms and we saw how they have a whole bunch of potential energy, and they give that energy away as they take or give electrons in order to get a full outer or valence shell. So here we saw that happening with sodium with its 1 valence electron and chlorine with its 7 valence electrons. Sodium can give that 1 valence electron to chlorine, and then the sodium becomes a +1 ion, and the chlorine becomes chloride, which is a 1- ion. And then those two ions stick to each other because electrically positive things stick to electrically negative things. And when two ions are stuck together, we call that an ionic bond. So this is an ionic compound made of sodium ion and chloride ion, and the name for this compound is sodium chloride. So if we want to figure out what the formula for sodium chloride is, what we need to do is we need to write how many sodium ions there are and how many chloride ions there are. And you can see here that there's just one of each. So here's how we do it. If you saw this, sodium chloride, and you wanted to take this name and turn it into a formula, here's what you'd do. You'd write the formula for sodium, and you'd write the formula for chloride, and then you'd get out your periodic table here, and you'd look for sodium, and you'd look for its oxidation number. Its oxidation number is its charge when it's stable. So sodium, when it's the most stable it can get, has a charge of +1. So I can just write that +1 right there. And then chlorine turns into chloride, which is the ion form of chlorine, and it is most stable with a charge of 1- or -1. You could write it either way, it doesn't matter. So to figure out the formula, what we're going to do is we're going to write it over again like this, and we're going to take the absolute value of this number right here, which is 1, and we're going to bring that number down here into the subscript position. This is the superscript position up here in the top right. That indicates charge. This is the subscript position down here in the bottom right. And that indicates how many ions we're talking about. So we're talking about 1 sodium ion here. And we're also talking about 1 chloride ion. Because remember, sodium chloride has 1 sodium ion and 1 chloride ion. So the formula for sodium chloride is just NaCl, because in chemistry, 1s are invisible. So if we drew a picture of it, it would look like this. We'd have our one sodium ion and our one chloride ion, and they'd be stuck to each other like that. So anyhow, this is the formula for sodium chloride right here. We'll do another example. Magnesium chloride. So first thing we're going to do is write the symbol for magnesium. I just know what it is because I've been doing this for a while, but you could just find magnesium on here. It might take you a while. It's right here. The symbol's Mg. And then we would never find chloride on here because chloride is the ion form of chlorine. So instead of looking for chloride, we'll just look for chlorine here. And here it is right here. And chlorine, we already know, has a charge of 1 minus. So magnesium, sorry, back up. Magnesium has a charge of 2 plus when it's its most stable. That's its oxidation number, 2 plus. So magnesium has an oxidation number of 2 plus. Chloride has an oxidation number of 1 minus. I'm going to write them again. I'm going to take the absolute value of this number and bring it down here. Take the absolute value of this number and bring it down here, like that. And then I'm going to drop any ones that I have. So the formula for magnesium chloride is going to be 1 magnesium for every 2 chlorides, like that. And if we wanted to draw it, here's what it would look like. We would have 1 magnesium ion. And the reason there's 2 chloride ions is because chloride ions only have a charge of 1 minus and magnesium ions have a charge of 2 plus. So we need 2 chloride ions for every 1 magnesium ion. Ionic compounds, this is an ionic compound right here. Ionic compounds are always electrically neutral. So you're going to have as many of the positive ions as you need in order to electrically neutralize all of the negative charge you have in here. And soon you'll notice that with this staircase right here, pretty much everything on this side of the staircase is positive, and everything on this side of the staircase is negative. So we'll do one more example here. Aluminum oxide. Thanks. So we'll start by finding the symbol for aluminum, which is right here, and then the symbol for oxygen, which is right here. And aluminum has a 3 plus charge right here. Good job, girls. Bye. And oxygen has a 2 minus charge right here. So next we're going to take this 2 and bring it down here. Take this 3 and bring it down here. And we don't have any 1s, so we don't have to simplify it anymore. That's the formula for aluminum oxide. And here's the justification. We've got aluminum ions that have a charge of 3 plus. And then we've got oxide ions with a charge of 2 minus. And we're going to need 3 of these oxygen ions or oxide ions in order to balance out the positive charge. Oops. 1, 2, 3 oxides, 3 oxides, and 1, 2 aluminum ions, 2 aluminum ions. So this just models the same thing that this models, which is the ratio of positive ions to negative ions.